Hey folks, Mr. Dollar here again. I'm looking at this is part 2 of this sequence question. We are exploring these sequences as arithmetic and geometric. This is coming from Math 1, CPM Math 1, number 109. So I got cut off here at this sequence 3. We were determining the next 4 terms. So what we did determine was that the pattern is being multiplied by 5 each time, right? Because that's the common ratio. Remember, to find common ratio, it's just take uh, the one term and then like the second term divided by the first term, the third term divided by the second term, right? So you divide consecutive terms, and then that's how you find that common ratio. So my ratio we determined was 5. So I'm multiplying by 5 each time. So I got 25. Now it'll be 125 is the next term, and then it'll be 625 is the next term, and then it'll be 3,125, right? So every time I'm multiplying by 5. So there's my next 4 terms. So what is my how do I write my ratio? Oh, and by the way, I noticed too in the last video I was writing using x and y, so I made a change here. I was supposed to be using t of n, so really this should have been written as t of n is equal to 4n minus 2 instead of the y equals 4x minus 2. But either way the equation is written would make sense to me. And then but I'm using it, putting it in t of n instead of y is in an x. So I'll do this one as a t of n. So t of n is equal to what? Well, the common ratio is 5. So I know it's 5 to the n, right? Every term number is being multiplied by 5. But what would have been that initial term, right? So if we go backwards, I'm going to divide by 5 to determine that 0 term. So 1 divided by 5 is 1/5. So there's this t of n for sequence 3 as a geometric. So last part here talks about create a totally different type of sequence for each pair of values shown above based on your own equations. Write your equation clearly using words or algebra so that someone else can determine the next 3 terms you want. So if I started off with that sequence 1, right, that first sequence, the sequence 1 started with 2, and then it went to 6, and then we had a 4 term. So the 2 types we've already explored were arithmetic and geometric. So we're going to do something that's not arithmetic or not geometric. What could that be, right? Could it be something that's quadratic, right? Could I take and square the n, right? So if we let me play around with that. There's different things you could do, or we can just do a recursive uh, equation to determine it. So there's different things we could do. Remember, if I made a table here, my first term is 2, my second term is 6. So I have to find an equation that's going to give me each of these, which is not easy to do when I think about it. If I'm going to try to make it a quadratic or something that's not arithmetic or not geometric. So I'm going to just use a recursive equation, one that maybe adds the previous 2 terms. We've done that before, right? So you can do all kinds of, get creative here. So I'm going to use a recursive equation. My recursive, remember to write a recursive equation. So the recursive equation is in the form of your t to the n plus 1 means the next term. And for me, I'm going to say is the term I'm at, and I'm adding it to the previous term. So that would be n minus 1. So if I take and add the 2 terms, the 2 previous terms, that's what this says. So to find your next term, that's your t plus 1, I would take the term before it, that's your t of n, and add it to the term before that. That's the t of n minus 1. So this is the 2 previous terms, right? So basically 2 previous terms. What we're going to do, if I was writing it in words, I would say add 2 previous terms. Okay. So I would say, well, then my third term would be 8, because I would add those 2 together, 2 plus 6. And then my fourth term would be 14, because I would add 6 and 8. And my fifth term would be 22 because I'm adding 8 and 14. And then my sixth term, my next term would be adding those two, which would be 36. So you could say this is the equation, a recursive term. Oh, I also have to define in my recursive term, define my first term. So I'm going to say that t sub 1 is equal to 2. So, and actually, if it's recursive or it relies on two terms, I also have to define my second term. My t sub 2 is equal to 6. So I got to define my first two terms if my recursive equation is based on adding them to. So that's one idea of what you could do with these terms to create a whole different sequence, something that's not arithmetic, something not geometric. Okay, there's some examples. There you go.